Hi, everyone. Okay, so this refresher is about the distributive property and the area model. So there are ways to do this without the area model. And if you're at that point, great. But I imagine if you're watching this video, maybe you'd like a refresher. I know that's the name, bad joke. Okay, so how do we set this up? Well, this is our length and this is our width of our area box. Okay, so this is our length, 5x, and this is our width, 3x and 2. When there's a plus, you make kind of a separator. So then the area of this box is 3x by 5x. And so we have 3x times 5x. Now, one way to write that is you group the numbers and then you group the variables. 3 times 5 is 15. X times x is x squared. So the area that goes in this is 15x squared. Okay, now you don't have to pull it apart. I just think it's really helpful to see it in what's actually going in this. Now, this box, what's going in this box is the area of this rectangle. This length is still 5x, but this width is 2. And so to find the area, we get 5x times 2. We group the numbers, 5 times 2, and then we group the variables. So we get 10x. Okay, so then how do we take all of this and put it in as an answer? So if I use a different color, what we gather from this is that the total area is this plus this. So my final answer is not this box. But when I multiply this times this, I used this tool. The tool is not the answer, but I used this tool to find out that this is equal to 15x squared plus 10x. Okay. Someone in one of my classes was asking, like, I'm having trouble understanding what all of these pieces are. This, if we're thinking about the area model, these are the dimensions. So the length and the width, okay? And once it's distributed, this is the area, okay? So now if we look at a slightly more complicated problem, or at least it feels more complicated for most of us, if I go down here and I do this example, so now if we have 8xy times 3x squared y plus 4xy minus 8x. Okay, now there's a lot going on there, right? We've got lots of variables, and the more variables, it just feels more complicated. So I'm still going to go back to my basic model of length and width, length and width. And so when I do that, this is 8xy, and then I've got 3 sections here, 3 terms, which means 3 boxes. Okay, so this one is the first 3x squared y, and then 4xy and negative 8x. So then when I do this, I'm going to find the area of each of these boxes. So this box is going to be 8xy times 3x squared y. And I'm just going to group everything up. Again, these steps let us break this problem down into something more manageable. So this becomes 8 times 3 times x squared times y. I got everything. 8 times 3 is 24. X times x squared is the same as 1, 2, 3, 3 x's, which is x cubed, and y times y is y squared. This box is 8xy times 4xy. 8 times 4 is 32. X times x is x squared, and y times y is y squared. And then my last box is this times this, 8xy times negative 8x. 8 times negative 8 is negative 64. X times x is x squared, and y is y. And then when I put this all together, all of this multiplied out gives me, so this whole problem gives me 24x cubed y squared plus 32x squared y squared plus, or minus actually, because adding a negative, 64x squared y. Sorry, I had to kind of go below there. Okay, so the box method allows us to have a method for organizing our information.